again, these are long problems. There's no doubt about it. But the first and absolute first step of the problem is to do the partial fraction decomposition. And when I did that, you should be able to reproduce this thing just by saying what to do. And I will indicate what I mean by that. If you're doing this over here, what you'd say is, gee, I don't know 1 minus x plus bx plus c over 1 plus x squared. And then you got to figure out the a, b, and the c. My belief, though, is if you do that, the a is going to turn out to be 6, the b will turn out to be 0, and the c will turn out to be minus 5. All right, so if you do this, a should turn out to be 6, b should turn out to be 0, and the c should turn out to be minus 5. So again, this is goal number 1. All right, you can reach that goal. Good for you. Goal number 2 is the expansion. All right, I just want to briefly go through that without putting all the details down. All right, but partial fractions, goal number 1's there. Now, by the way, looking at this one over here, the first one looks trivial to me. It's 6 times 1 over 1 minus x. What would that be? 6 times 1 plus x squared plus x. Whoops, I'm sorry. I made a mistake and I did. Just daydreaming. I got to erase that. X squared, x cubed. I did it again. I think you get the idea. Yada, yada, yada. So this is, I say it's trivial. It's right there. It's super simple. What's the next one going to be? And I'll write it down for you. A little more complicated. It's minus 5 times 1 over 1 minus a minus x squared. And by the way, I also see this being somewhat trivial. It's minus 5. You're going to get 1. Then you're going to get plus minus x squared. Then you're going to get plus minus x squared squared plus minus x squared cubed plus yada, yada, yada. And if you did that, minus 5, 1, minus x squared plus x4 minus x6 plus yada, yada, yada. All right? I want to point out I see that written. They write a little funny, though, but it's really the same thing I wrote up here, but they just multiply through it by 5. They get this thing over here. All right? Then the problem comes is you gotta combine the two. All right? Now, again, I'm not saying it's easy. I'm just saying you should be able to do it. Right? Just like we've done in the past problems. And your goal is to get this over here. This is the final goal. In the final goal, there's actually 2 steps to it. Right? This one's fine. If you get this and you're happy, I'm happy for you. If you want to go further, get this one over here, I'm happy for you. Whatever one you're getting is fine by me. Does it take time and effort? It does. This takes effort. However, I want to point out, we've done quite a few examples in the effort department. Did they take time? Of course they take time. But we've done quite a few examples already. We are hoping that you're at the stage where you can do it on your own. All right? I do want to remind you, though, my name, Ron Bannon. And again, if you're following this long, you probably know this at this point. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. And again, my encouragement to you is if you do reach out to me at this email address, and I'm not overwhelmed, I will get back to you. What are we looking forward to? Hearing from people that have constructive criticism that will improve this document, all right? Now, granted, nothing is perfect. The videos aren't perfect. Sometimes I'm quite sloppy in the way I'm doing something, but we're basically just talking through the document. The videos are supplementary, all right? It's not a complete course in this. It's not like a complete course like you're taking out of school and the teachers are going through this for you. And by the way, if it were a complete course, and I'm often surprised by this, when Wells taught this course back in 1904, I shouldn't say he taught the course, he wrote a book where other teachers taught the course, and he probably taught a similar course at MIT. And you might be surprised to hear that at MIT, they were teaching algebra back in 1904. And you may wonder why that is. Education back in 1904 in the United States was, it wasn't so heavy in the math department. Now, there was a transition there. I mean, I'm not saying it wasn't difficult. Their high school curriculum was quite difficult back then. They might have been studying Greek and Latin, really difficult literature, writing. They certainly were well educated. I'm not saying they weren't, but they really weren't spending as much time as we spend now in mathematics in high school. Now in high school, I mean, some high schools are pushing students towards differential equations, linear algebra. They really are quite aggressive. And the belief there is that math is really important. I actually think just the opposite. I think those other courses are really more important at that stage of a student's life. But students should be exposed to mathematics just like they should be exposed to literature, just like music, art, a lot of different things. And why is that? To have a broad education. And I really do believe Wells's treatment of algebra is a very broad treatment of algebra. He does an excellent job. Nowadays, this course just would not float in just about any school in the United States. No one would entertain this level of difficulty in a course. But it's really a good foundation in algebra. Thank you so much for listening.